When I was younger, I always took apart everything I got. Just a few years ago, I finally learned how to put everything back together, and everything took off from there. When I was 14, I came up with this idea. It was to create a robotic hand controlled by a wireless control glove. Now, I was 14. This was a pretty far-fetched idea for me. It was one of the most practical ideas I've had so far, but I had no idea how to make this into reality. I turned to the internet, and I instantly found a lot of sites that really promoted learning and made learning fun and easy. These sites include SparkFun, Instructables, Hackaday, just to name a few. From there, I started actually building. I started, as you can see, I started using electrical tubing, a lot of electrical tape, and Legos as supports. That's just what I had laying around, and I wanted to make use of it. I like to work fast, and this is the product of it. So throughout learning, it was a challenge. I live in a small town in Colorado, so I'm very limited. I don't have big universities to go into and ask questions. I had the internet and my bedroom to make everything out of there. For example, for the flex sensors on the control glove, I first learned how to wire those up to a microcontroller, then write code for them, get all the raw signal values from those, convert that into motor signals, and then actually move something with that. Then add wireless radios and make everything work in unison. If you times that by 5, you get individual finger control of a whole hand. Now, I didn't stop there. I wanted to make something bigger, better, and more functional. I started learning modeling software, and I wanted to get this made physically, and I was going to go with CNC milling or something like that. And the cost was outrageous. So there was this new evolving technology that started coming into play, which is 3D printing. I sent this to a few companies, and I was getting quotes upwards of $500 just to print the hand. This was the point where I almost quit. I didn't have $500 to put into something that could just fail. And so I really looked around and tried to use my resources as much as possible. I had a friend that lived in New York, and he worked at a 3D printing company, and he had a printer of his own, and he threw it on one night, and I had to pay for shipping. So this was really, the spark of this, contributing and making everything possible. Now I wanted to increase functionality, and with that you need stronger motors and better electronics and everything. And I was 16 at the time. I didn't have a whole lot of money to put into this. I pretty much had the money from working over the summer. And so I had to find compromises between different technologies, different motors, and incorporate all into one system. So I needed an extremely high torque motor with a really precise feedback system. And that alone already sounds expensive. What I ended up doing was I used a DC motor with a gearbox, a really beefy gearbox, to really get the maximum torque out of a simple motor. And I put a potentiometer on the end of the shaft. A potentiometer is what's found in light dimmers, so again, keeping the cost extremely low and increasing functionality. So in the end, I built this robotic arm up to the shoulder, which was extremely strong. It could toss balls to you, it could shake your hand, it could pretty much do anything a human could if you program it correctly. From there, I entered into the science fair in Colorado, and at the state science fair, I kind of had an aha moment. This 7-year-old girl came up to me. She had a prosthetic limb from the elbow to the fingertip, one motion and one sensor. I started talking to her parents more about it, and just that alone was $80,000, which is a lot of money for anyone. And I could see the distress talking to her parents, just because that is a lot of money. And the thing was that she was 7, so she would probably need about 2 or 3 of those within her lifetime. And that was the aha moment for me. I could take what I was already doing, transfer that directly into prosthetics, add a control system, and it could have the potential to save and make life that much more enjoyable for amputees and already prosthetic users. Now, there are other prosthetics on the market. The main control system for the newer advanced ones are all neural implants, which is an open spinal surgery, which is extremely dangerous. It's an open spinal surgery where they implant sensors into your spinal cord that pick up your neurons. That's dangerous and also costs a lot of money, which is, I don't have money to do that, so I wanted to find a compromise. I started looking around, and I wanted to keep everything external. I want to get rid of all the surgeries, and just have something simple that you could put on every day, take off whenever you need to, and conceal within something that's easy. This is the EEG headset. This reads about 10 different channels of your brain, and with this you can do a lot. This is all wireless. It actually uses Bluetooth, and so this is the newer arm that this is actually controls. And although it's only sending data a few inches, that adds to the prosthetic. That eliminates the wires going from your head to the arm. And for prosthetic users, that's a big psychological aspect to it all. Now the cost for prosthetics is outrageous. The newer ones, I don't even want to say the price of that. I was able to make this whole physical arm that has the same functionality as a human arm, the same degrees of freedom, and almost the same strength, which is extreme. And I was able to make this whole physical model with this whole neural control system for right about $400. A lot of, thank you. And I could guess that a lot of the phones in your pocket right now cost more than that. So, now, I was able to make this so cheap and affordable because of 3D printing. I actually have 2 3D printers in my room where I'm able to make each individual part, each individual fingertip, and that's what really sets this apart from anybody else, is that I can make custom gearboxes. I can really increase the functionality within a few days of just prototyping and finding new ways and new technologies to incorporate this. Now with prosthetics, there's an appearance issue. That people, some of you might want this really cool-looking, futuristic robotic arm as a limb, and others, they want something that looks and feels and looks just like a human arm, skin-wise and everything. And that's what 3D printing has allowed me to do, was create really organic-looking objects and fingers and the whole shape, the whole basic shape of it all. And so that makes it easy to put silicone skin around it, and that also decreases cost because it requires less silicone, and also make it look more human-like. Now there were some innovations that I used within this. 3D printing usually comes out within layers. It looks kind of choppy. And what I actually did was I heated acetone up to 110 degrees Celsius where it starts to vaporize. I collected that vapor and I had it condense onto the 3D printed objects. That gives it a really clean, glossy finish. And it sounds very dangerous. I actually did this in my bedroom within mason jars. Something about my bedroom, but so already it's starting to change people's lives. This is really becoming practical in the real-world applications. Prosthetics is the main application for this, and there's a lot that this can change. I'm already working on newer hands, which currently I have all the motors within a form. I have a new design where all the motors are concealed within the palm of the hand, still the same size, and I get over twice the strength of what I have now. Already that I can almost surpass human strength. Already I'm looking at over 50 pounds of torque per finger, which is extreme, well, almost dangerous extreme. And actually currently I'm living in Houston working at NASA, part of the Robonaut project. So transferring a lot of this technology to what they're doing. And I'm not stopping there. I want to help people. This has turned into something that I started from boredom into something that could change people's lives. And already I have plans to help the deaf hear. And actually, I have a little side project. There's this boy at my school that was in an accident, and he was paralyzed from the waist down. And there's a 2% chance that he'll walk again. My goal is to create an exoskeleton pair of legs for him so he can actually walk for graduation. My goal is to help people, and yeah, it's really turned into something that I never expected. I believe this is the future, and this is just the start of it. And what's gotten me here is curiosity. Curiosity is in every part of us, and it's what makes the world go round, and it's why we're here today. So I challenge you to challenge the system and to look beyond all the boundaries and to be curious. Thank you.